Good afternoon, everybody, and welcome to Agrifood Conversations brought to you by iSelect Fund, the Van Trump Report, and the Yield Lab Institute. My name is Tom Bunn. I'm an associate on the iSelect Fund team, and I'm excited to introduce our speaker today. Agrifood Conversations is all about driving innovation in agriculture. Each month, we highlight a specific theme, including emerging topics such as soil health, plant genetics, vertical farming, or aquaculture, to name just a few. Today, we are joined by Jeff Hallowell, founder and CEO of Biomass Energy. Biomass was founded in 2015 as part of the BMGF Re-Invented Toilet Challenge, and its patents are based on protecting the environment and returning nutrients to the soil. Its products include a biogenic refinery for waste treatment, as well as systems management solutions and other engineered sanitation products. Each of you knows companies are more likely to succeed with the right network of customers, talent, investors, and advisors. We've invited you to this call because you are some of the smartest, most talented people in Jeff's market. You are potential customers for their products and services. You built and sold a company in the agri-food industry, or you are a sophisticated business person who understands the agri-food market and the challenges it may face. Before we get started, we do have a quick poll question to get a better idea of who we have on the call today. Please take a few seconds to answer. Finally, a few process comments before we get started. We are not soliciting investment. This presentation is to provide information about Biomass's products and services to help them find customers, mentors, and other strategic relationships that can help them grow their business. You are all also on mute. You can use the chat window to ask a question. After the formal part of the presentation, we will answer as many questions as time allows. Finally, this presentation is being recorded and will be available for replay. So without further delay, I'm pleased to introduce Jeff Hallowell, CEO and founder of Biomass Energy. Jeff, take it away.
Thank you very much.
Biomass Controls.
Really yes. Thank you, Tom. So as Tom mentioned, we're with Biomass Controls. We're located in Connecticut, but we also have locations in North Carolina and also employee in Switzerland right now. Just a quick introduction. I'm going to go over these 7 items. That's actually a picture of me standing in front of our system in Warangal, India. Our refinery is actually inside of that container. So the first thing we're going to do is go over the problem. So the problem, first of all, is with human health. So about 200 million tons of human waste go in untreated every year, and they typically go into the water. So this is not really far from what really is happening is that our human waste, even if we have sewers, are being piped right into the water. And what that causes is, of course, disease. So what you won't see in the paper every day or read on the news or see on the news is that over 2,000 children die every day from sanitation-related diseases. So almost 2 billion people drink water every day that's contaminated with feces in it. Sometimes you'll go down to the beach and you'll see the beach is closed because the levels are above normal. So there is always some presence generally of feces in the water, particularly around older cities. What that happened is not only outside of the US, but also it's happening in the United States. So this used to be a coral reef. This is a reef that's off of Maui. A lot of folks don't know is even in Hawaii, about 55 million gallons of sewage are being dumped into their water aquifers into the ocean every day. So that's the problem we're trying to save. It's really basically, it's human health and it's protecting the environment. In New York, they actually have a resource locator that they've started. And you can see from the window on the left in the legend that they're starting to track the sources of organics. As landfills are filling up, they're starting to close them. And the first thing they're prohibiting is organic material. And while there are other solutions to handle it, there's always a residue that needs to be dealt with. And that's what a part of our solution is. So our mission is really around decentralization. Similar to the computer industry, where back in the 70s, everyone logged into a mainframe. Most infrastructure right now is based around World War II type technologies that are centralized. And so our vision is to have a decentralized solution where we're reducing transportation costs, which are generally the highest cost for these types of materials, and the costs around it as well. We're also focused on promoting gender equality. At our sites in India, for example, there are women who are actually the managers of the site. So this is a new industry and certainly a great opportunity for women to be part of it as well, as it really affects them the most. So our product is a a biogenic refinery. And so why organic means once living, biogenic means from living. So there are a lot of things, textiles, human waste, manures, and other things that are what we consider biogenic materials. And you're starting to see more EPA documents that are referring to biogenic materials as well. So ours is a thermochemical treatment solution. So some of the advantages of that is that it does provide a pathogen-free output. Also volume reduction, typically 90–95% reduction. Our goal with this system here is an energy independence that actually has enough thermal energy to run itself. And what the benefit is also nutrient recovery. So we have systems in the top left there, that's in Alaska, and that's for a small village up there. And so cold climate is really good for thermal solutions. Also bottom right is in India. It's another one of our facilities there that we're working on with Thai technocrats out of India. But the whole point of decentralized is to bring the treatment closer to the solution. Closer to the material. As it says down below there, we've done it with human waste, manures, food waste, ag residues, and also textiles. Part of our technology you'll see later on is really dealing with the emissions control, is to make sure that what we're doing to try to keep the water and the soil healthy is also not polluting the air. And also a benefit for us is the remote monitoring capabilities, so that even the systems in India, we're able to access and view them as well. The key to our technology is, and really from an investor perspective, is our patents. So while you can see the patents on the left side are really more focused on air quality, on the bottom right, it's really about nutrient recovery as well. And on the top right, it's about fuel feeding, is basically how does a material go in, how do we handle it? And then we also have patents in our controls and our software as well, which are in the bottom right there. So we believe in data-driven solutions. From the beginning, we measure everything. We believe in evidence-based treatment as well. So under EPA 503 for time and temperature, you really have to show that it was treated and the material going in and out, and at what levels and what temperatures it was, and how long was the residence time. So this is just one example of some of the data that comes out of our system. There's lots of different options out there. Most of them have been around for thousands of years. There's really not a lot of innovation there. We believe that so this is where we position ourselves on this 4-box model, and our goal is to move up into the top right corner. So we're going to outline here 5 vertical and 5 horizontal markets. So food production is a really big market. For every pound of human waste, there's 4 pounds of food waste. And so it's a huge market. Manures is obviously one of the areas that we've been focused on, but also ag residues, market waste, things like grocery stores, they have expired bread or vegetables that they need to get rid of. Also working with operators, so the sanitation market. So people that are actually running facilities that are currently now paying a tipping fee where they might be hauling the solids off to a landfill, and that landfill might not be available, or they might be in a remote community where it costs them a lot of money to transport it as well. Landfill waste, diverting waste from landfill. In the US, about 30% of the waste is organic or materials that could be processed by our system. With volume reductions of about 90%, it also can reduce the amount of material and the cost as well. The portable market, emergency, when you don't have electricity or power, military, islands, so basically remote communities that, again, the transportation costs or the needs based on the infrastructure it has is not able to support it as well. And then the data market. So a lot of the data, while we use it for doing performance evaluation and looking at our key performance indicators, the real customer for that often is the regulators, to really to make sure that we are compliant and that that we're achieving the outcomes that we want. In the horizontal market, a big focus area is climate impact. So not just nutrients going into the ocean like you saw with that coral reef in Maui, but also looking at greenhouse gas reductions as well. In some areas, nutrients are going into the water and they're causing algae blooms, which are deadly as well. And also the circular economy, or even sometimes you could say closed loop or reverse linear, where we're trying to treat the material and reduce the volume and do the nutrient recovery on site, try to keep it as close to the source as possible. And that really gets into volume reduction as well. So if you have to transport material that might be 35, 60, 85% moisture, it's very expensive to haul water. And so basically by using the thermal treatment, you can reduce the volume and also reduce your cost of transportation. For harsh climates, like the one you saw in Alaska, a lot of the biologic systems they like about 20 C or 68 degrees F to operate. So if you're in a cold climate, you have to heat them. And so thermal solutions work really well there also. Pathogenic treatment, again, for compliance, the World Health Organization, EPA, and also there's two emerging ISO standards, one which was recently passed, which is ISO 30500, and also a new one that's emerging, which is 31800. So the 30500 is for on-site treatment, primarily for human waste, but the ISO 31800 is for decentralized or small community-based, where 51% is human waste and 49% is some other biogenic material, such as what we've talked about earlier. Data evidence, again, for compliance. Also, for a lot of these contracts, I think they're going to be moving more to service level agreements. So you're going to need to commit to a certain percentage of uptime. And again, with the data to prove that it was up, that can affect your profitability and also be used to compare many systems as well. As the Internet of Things come out, or we sometimes say the Internet of Toilets, it's also going to the farms. So farms are becoming smarter as well. And so understanding and trying to loop that in as a small city in itself with all the different sensors and all the animals there as well, it's really important to do that and to merge that data together as well. So the sanitation market, which is fairly well defined, more so than the others, generally we know it's a very big market with about 4.5 billion people that don't have access to safe sanitation. If you remember back to the Olympics a few years ago in Brazil, where the rowers were getting sick from all the sewage in the river. So there's a lot of untreated material out there, and it's a very big market. The United Nations really focus on a part of SDG goal number 6, and specifically 6.2. But actually, there's about, of the 17 UN Sustainable Development Goals, 14 of them really relate to sanitation or biogenic materials. And there's some of them there, but basically they all are, interrelated. And so if you don't have water, if you don't have good sanitation, it really does affect a lot of the other things. And nutrient recovery is also a key part of that. So what are the impacts? So we do have folks now that are also using the data to measure the impact. So a big one is on women and girls. So in a lot of places in the world, for exactly about 20% of schools don't even have bathrooms. And typically women and girls will drop out and they don't continue. So it's a big effect on them. Also, going to get water is also a reason why sometimes women and girls aren't advanced and can't stay in school as well. So SDG 4 is education, SDG 5 is gender equity. Environmental protection, again, we talk about water, air, and soil. That's really important. So for some, it's kind of a return to Eden, is how do we clean up the environment and reverse the damage that we've done and move it back to more health. As far as people are concerned, under SDG 3, there's this concept of One Health. So while we've been focusing a lot on sanitation, really looking at all the streams of biogenic material in a community is really important to really make sure that you're providing a holistic solution. And that's really under that One Health concept. For economic impact, as you start to provide systems to recover nutrients and waste, you also start to have jobs that are available. So it's a new industry, and that also helps reduce poverty as well. And then the last one we talk about is resource recovery. Basically, things like phosphorus are very finite. Once it's gone, it's gone. They mine it in a couple certain places, and in about 2030, it'll start disappearing. So how do we not only really recycle, but reuse those and put them back in right where they are, right where they're being used? Here's just a quick example on climate impact for a dairy cow, or dairy farm. So most of the climate issues is really from the solids that are in the manure. So if you can take the solids out, you can cut down the greenhouse gases in half. And then what do you do with the material? So you can also run them through our system to reduce the volume, but also to preserve the nutrients so that you can put it back into the soil. So here's 3 different kind of flowchart analysis that give you the different markets and some of our partners in here. So again, we started off in 2015 as really coming off a couple of years where I was involved with the Re-Invented Toilet Challenge as a contractor and working to do what they call an omni-processor, or to process materials in communities under 10,000 people. When we actually were doing that, we actually used livestock, mostly hog manure, as a surrogate for the human waste because it's different out of a person than it is in a sewer, for example, or septic. So we used the hog manure as a surrogate, and now we've kind of come back full circle on that. Now using hog manure and cow manure also as a feedstock as well. But in parallel, over the last several years, we've been working with Rochester Institute of Technology, and they actually have one of our refineries, and they've been doing a lot of tests regarding institutional waste, food waste, digestate coming out of organic or out of anaerobic digesters. And so there is a lot of work being done, but the process in the back is the same. And what this diagram really illustrates is that the pre-processing is what's different for each of these. The source of the material, how it's pre-processed, but the back-end process is very similar. These are some of our partners here. Recently, we've just signed an agreement with Bauer Fan, which is for our integrated separator. That's going to be part of our livestock solution. Today, I'm actually at NC State. We're working with them. Cornell, we worked with for some time, mostly in the soil side. Johannes Lehman up there, who's recognized as one of the top in biochar also. And of course, we got all this started thanking to the Bill and Melinda Gates Foundation for their support early on. And Native Energy is our partner for carbon and carbon credits. And they have a lot of partners who they work with. So they're our third-party validator. USDA has also given us some funds recently, which we'll talk about later. And we're currently set up at a place called Fairview Farms, which is part of the Farmer's Cow brand. So here's 5 of our different projects that we're doing now. So they go anywhere from the systems that are being used primarily to reduce greenhouse gases by pulling the solids out of the cow manure. And again, some of these I've already mentioned before. So thank you very much. Appreciate your time and appreciate being invited on this call.
Thank you very much, Jeff. Very interesting stuff you're working on, and congratulations on the progress to date. Very cool stuff. So the attendees, to ask a question, you can either put your hand up and I can unmute you, or you can just type in a question on the question pane and I will read it out loud. But Jeff, I suppose to get things started, can you talk a little bit about traction and how many units you have operational right now and where?
Yes, so we've built 18 units to date. We have one running in Alaska and one that we're supporting here in Connecticut. We have 6 units in India, 3 of which are running. One is used for tests and one is used as a backup. Actually, we have a couple extra ones over there, but we have 3 running at sites there, one in Maharashtra, which is processing for about 20,000 people. We have one in Nasirpur, which is part of Andhra Pradesh, and that's treating for about 9,000 people. And we have one in Warangal, which is part of Telangana, and that is processing for about 15,000 people. We also have one that we're actually moving in here to NC State that will be working closely with them on the animal manures as well, and Dr. Josh Kearns on the biochar analysis. We have a system at Rochester Institute of Technology also that they're using for the food waste. And we've had systems in and out of Cornell, and we're looking to put another one in there now. So they're all different versions. We actually have one down here that's owned by Duke that's in our office here in North Carolina as well.
Fantastic. And what's the mechanism by which you are, getting these into the places that need them? I know you guys are structured a little differently. What's your go-to-market plan, if you will, right now, or plan, and what have you done historically?
So historically, we've sold units, and our plan moving forward is to lease units. So in the industry for treatment is typically a 10 or a 20-year lease. And so the goal, for example, of the Gates Foundation was a nickel per person per day. And that was going to be for on-site treatment, but we're using that model as our solids treatment. So basically, a unit running 10 hours a day, 300 days a year, that lease is $150,000. So it's very easy to figure out. On the cow side right now, we're probably around 24 cents per cow per day. And that's really where we're going in the long term, is we're really trying to drive it towards throughput. But for a lot of folks, doing it as a per animal, per hour, per person per day is a lot easier for them to get their head around. And our services we sell separately, so that we do all the monitoring, we do all the data reports for them. And our goal in the future is to have more value in the reports, such as adding things in for impact, like Iris Plus, Y Analytics. There's a couple other ones out there looking at the carb standard as well, so that we can provide those impact reports to investors and the farms and the customers as well.
Very cool. Can you talk a little bit about your experience with the Bill and Melinda Gates Foundation? Would love to hear kind of your history with them and what that process looked like.
Sure. So part of our earlier technology, again, like I said, was around emissions. And one of the, goals out there with nutrient recovery is making biochar. And so there's a lot of systems out there making biochar, but they couldn't meet the emission standards. And so we helped them do that. And that's really what it got us into the biochar market. And through that, we got involved with the Gates Foundation. So we were at a conference, a biochar conference, actually at University of Massachusetts. We met somebody there who invited us to be part of his team and to be part of, because he was already involved in the Gates Foundation. Since then, that was back in 2013. We brought a system to India in 2014. And that's when we actually spun Biomass Controls out as a separate company, really focused on this kind of high moisture materials that also needed to meet these EPA and other environmental standards. So our work through the Gates Foundation has been very rewarding, and they've been extremely gracious to us. We've worked as a contractor to several different folks here in the United States and also in India, and we've done some work in South Africa as well. But I think they have a great team, and our team, we get along really well. And but they're tough. I would say that they really look at their placement of funds as an investment and not a grant, because they're really looking for you to deliver results. So they're very tough as well. So it's been a very good experience for us.
Fantastic. Listener Alan Felton has a question. He asks, doesn't Asia have a long-term concept of putting their human waste into the rice paddy fields? This must work. Your comments?
Yeah, so that works fine for on-site, but if you start having to transport that, that's where the cost comes in. So if you can preserve those nutrients, that's what we're really looking for, and also stabilization to make sure that after the water gets in there, a few rains, that those nutrients aren't gone. So what our output, which is the biochar, basically holds those nutrients in there so that it's available for the plants as they need it. So biochar is also used a lot for erosion control as well. It's used for treatment of wastewater. If anyone has a fish tank, they probably have some carbon in there that's filtering the water as well. So it's a different product than just the manure. Also, our goal is to take the solids out so that we can reduce the greenhouse gases. Because when I grew up, I thought composting was a really great idea, but as you start looking at some of these operations, they're off-gassing a lot, and certainly to have those in a closed environment can be very expensive. So that's why running it through our system just makes more sense. and you're also taking carbon out of the plants and out of the plants that the animals have eaten, and now you're putting it back into the ground. So I would say that manure in the rice paddy is going to be washed away in a few weeks, where the biochar can last for hundreds or even in some cases thousands of years. So it's a longer cycle, and you're putting carbon in the ground versus doing the manure. You're putting, again, nutrients that are very short term. So it's a short term approach versus a long term. I hope that answers your question. You still there, Tom?
Oh, sorry, I was on mute there. Well, Jeff, I really appreciate it. If there are any other questions, either from the audience now or when people listen to it later, is there a good way for people to reach out to you with questions or comments or offering help?
Yes, absolutely. My email is jeff@biomasscontrols.com, and my phone number is 860-942-0500. And for more information, you can also see our website, www.biomasscontrols.com. Thank you very much.
Fantastic, Jeff. Really appreciate it. Very interesting stuff you're working on. Again, kudos to you and your team for working on such a noble cause. To everyone in attendance and to Jeff, we host these calls every week at 3 p.m. Central every Thursday. You can register for them by going to agrifoodconversations.com. And a replay of this webinar will be emailed to everyone who signed up and attended in the next 24 hours. So if you know others that may want to see this webinar and replay, please send them the register link, and they will get that access in their email inbox. So thank you again, Jeff, for your time, and thank you all to the attendees, and we hope to see you here next week at 3 p.m. Central. Have a good afternoon.
Thank you.